Okay, so in question 4, 1 cubed plus 2 cubed equals 3 cubed plus n cubed. So remember, 1 cubed is t1, 2 cubed is t2, 3 cubed is t3. This equals the sum. This is, in a way, is like Sn. It equals all the series put together. Okay. So what we're going to prove is that the RHS, LHS equals RHS. So for part 1, we're going to test P of Q. Okay, so we're going to test PQ. So what we're going to do is test P of 1. Okay, so for the left hand side, P1 equals 1 cubed, which equals 1. For the right hand side, it's going to be n equals 1. So we're going to have 1 squared over 4 into 1 plus 1 squared. So it's going to be a quarter times 2 squared, which is going to be 1. RHS equals 1. Okay, now that's part 1, that's part 2. Now, assume true for P of K. Now when you assume true for P of K, what we're going to get is 1 cubed plus 2 cubed plus 3 cubed plus dot 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 plus k cubed equals k squared over 4 into k plus 1 squared. Now that's true, you got to test for P of K plus 1. Now what we're going to get here is 1 cubed plus 2 cubed plus 3 cubed plus dot 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 k cubed plus k plus 1 cubed. Now you see that that's k plus 1 cubed there, okay? And what we can see is that the first k terms is P of k. And that's going to equal, now replace all k's with k plus 1, so k plus 1 squared over 4. And then replace k with k plus 1, so it's going to be k plus 1 plus 1, which is k plus 2 squared. Now, when you replace this with P of k, what we're going to get this replaced with is, it's going to be replaced with k squared over 4 into k plus 1. That's going to be plus k plus 1 cubed. And what that is going to equal is k plus 1 squared by k plus 2 squared. Now, what we might do here is we're going to work on both sides of the equation. So, I'm working on both sides of the equation. Or we might just see what we can factorize out. So that's k plus 2, that's k plus 1 squared. So if we work on the left hand side only, what we can do with the left hand side is we can factorize out k plus 1 squared. So what we're going to get is k plus 1 squared, and they need a common denominator of 4, so I'm going to have 4 in here and 4 in here as well to make them the same denominator. So it's going to be k plus 1 squared all over 4, and that's going to get multiplied by, it's going to be k squared here, and it's going to be 4k plus 4 in brackets. Next what we're going to do is we're going to factorize this, and we're going to get k plus 1 squared over 4, and when we factorize this, the reference number is 4, which goes in 2 and 2, which is going to be k plus 2 squared. And now all of a sudden it equals the right hand side. So LHS equals RHS, so that proof is done. So we got here is P of k plus 1 is true if P of k is true. P of n is therefore true by the principle of mathematical induction. Okay, so question 6. Now, in question 6, we're going to test P of 1. Now, when we test P of 1, the left hand side of the equal sign, which is this LHS, this is the RHS, and what we're going to find is that the LHS is going to equal, it's going to be 1 divided by 1 multiplied by 3, which is a third. The RHS will equal, n is 1, so remember n equals 1, so it's going to be 1 divided by 2 times 1 plus 1 equals a third. And then we're going to, once we test that, that's part 1. Now part 2 is assume true for P of k. Assume true for P of k. Now, in P of k, what we're going to see is that it's going to be 1 over 1 multiplied by 3 plus 1 over 3 multiplied by 5 plus 1 multiplied by 5 over 7. Then it's going to be plus dot 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 plus 1 over 2k minus 1 to 2k plus 1. That will all equal k into 2k plus 1. Now, we're going to have to test for P of k plus 1. So what we have here, just going to copy this part here, clone even. There we go. So that's half of what we need here for P of for that part there. So we're just going to space it in a bit more. So plus 1 over 3 multiplied by 5 plus 1 multiplied by 5 over 7 plus dot 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 plus, now this is the kth term, 2k minus 1 all over 2k plus 1. If you will, this is the Tn, so we have to find out what k plus 1 is. So we're going to replace k with k plus 1. So therefore 2k minus 1 is going to be 2k plus 1 minus 1. It's going to be 2k plus 2 minus 1. So it's going to be 1 over 2k plus 1. And then the other one after that is going to be 2k plus 1. So it's going to be 2 times k plus 1 plus 1. 2k plus 2 plus 1. It's going to be 2k plus 3. Now that's all equal to. Now we got to replace the k is here with k plus 1, so it's going to be k plus 1 all over 2k plus 2 plus 1, so it's going to be 2k plus 3 on the bottom. So 2k plus 3. Now, as stated before, this part here represents P of k. And P of k is represented by this number here, which is k over 2k plus 1. And this is the left hand side at the moment, and the left hand side plus 1 over 2k plus 1 into 2k plus 3 that equals the right hand side of k plus 1 over 2k plus 3. And once we've established that, we need a lowest common denominator. 2k plus 1, 2k plus 1 is there. So we're going to put a 2k plus 3 on the bottom and a 2k plus 3 here. We're going to multiply it out and we're going to get 2k squared plus 3k plus 1 on top. This is all the left hand side at the moment. All divided by 2k plus 3 into 2k plus 1. We're going to factorize this part here. Reference number of 2 breaks up into 2 and 1. So we're going to have 2k and k out multiplied by out using the reference number. So the reference number would be 2 and 1, so it would turn into this 2k squared plus 2k plus k plus 1. Then we'll bring 2k into k plus 1 plus 1 into k plus 1. So it would have turned out to be 2k plus 1, k plus 1. And that's going to be all divided by 2k plus 3 into 2k plus 1. 2k plus 1's cancel. And we're left with k plus 1 over 2k plus 3, and that also equals k plus 1 over 2k plus 3. LHS equals RHS. So what we're going to have here is p of k plus 1 is true if p of k is true. P of n is therefore true by the principle mathematical induction. Now, question 7. So what we have this time is that the sum of a series where your first term is S1. First term is 1, so it's going to be T1 plus T2 dot 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 plus all the way up to Tn. That equals Sn. Sn is this here, the RHS. So Sn is the RHS and the T1, T2, 3 are the Tn's. So what we got to prove first, prove for P of 1. Now P of 1 is basically, I'm trying to prove that T1 equals S1 according to the formula. So T1 is therefore 3 times 1 minus 2. And basically proving that the left hand side equals the right hand side. So the left hand side plus 3 times 1 minus 2, which is going to be 1. The right hand side is therefore equal to, remember n equals 1, so it's going to be 1 over 2. The 3 times 1 minus 1 is going to be half 2 equals 1. Therefore LHS equals RHS for 1. Okay, so that's step 1 done. Okay, I'm not going to reuse it. Now step 2. Step 2 is assume true for P of k. Now when we assume true for P of k, what we're going to get is this. We're going to replace n with k. It basically means n equals k. So we're going to end up with k, r equals 1, 3k minus 2 equals k minus 2. And then, remember this is the Tn formula. Okay, and then it's going to be 3n minus 1. Now remember, this here is the sum of k terms. It means t1 plus t2 plus t3 plus dot 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 all the way up to tk. That's what that means. Okay? Now we're going to true. For part 3 we're going to prove for p of k plus 1. And when you prove for p of k plus 1, we're going to replace k with k plus 1. You're going to place r equals 1. And then you're going to have 3 times k plus 1 minus 2, which is 3k plus 3 minus 2, which is going to be 3k minus 1.
Good morning and apologies for interrupting classes. Congratulations to the school golf team whose big win over St. Conleth's yesterday. There will be a meeting for any golfers from first.
Sorry guys, just scratch that last part there. Actually, it's basically TN. So sorry, I don't change the general term. The general term stays the same. I can't change that formula. I just have an extra term. So basically k plus 1 means that I have tk plus 1 at the very end. So that's what the k plus 1 term means. Excuse me for that. But on the other side, the Sn formula, I'm now looking for s of k plus 1. So I can replace k plus 1 in there. So k plus 1 over 2 to 3 times k plus 1 minus 1. And what we're going to get is k plus 1 over 2. 3k plus 3 minus 1, 3k plus 2. So that's what the proof it turns into. Now, this here, this full part here, means t1 plus t2 plus dot 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 plus tk plus tk plus 1. Now, I can figure out what tk plus 1 is. So what we have here is this whole part here, the sum of k terms, is basically k over 2 into 3n minus 1. So k over 2 to 3k minus 1. The t of k plus 1, remember tn is 3k minus 2. Therefore t of k plus 1 is basically 3 into k plus 1. Oh, sorry, that's 3n minus 2. So it's 3k plus 1 minus 2. It's going to be 3k plus 3 minus 2, which is 3k plus 1. That's going to be plus 3k plus 1. Now I have to prove that the left hand side here, this left hand side, equals the right hand side of k plus 1 over 2 into 3k plus 2. That can be all over 2. Now, what I'm going to do first and foremost is add in the number 2. So I'm going to put a 2 on the top and 2 on the bottom. Once I do this, I'm going to multiply out. I'm going to get 3k squared minus k plus 6k plus 2 all over 2. And then I'm going to turn that into 3k squared plus 5k plus 2 all over 2. I'm going to do a reference number. The reference number is 3 multiplied by 2. 3 multiplied by 2 is 6. 6 we have to turn into 5, so it's going to be 3 and 2. So what we're going to get is 3k squared plus 3k plus 2k plus 2. I'll get 3k into k plus 1 plus 2 into k plus 1, 3k plus 2 into k plus 1. That's the answer. So that's going to be 3k plus 2 into k plus 1 all over 2. Now once we've done that, what you can see next is that the left hand side equals k plus 1 into 3k plus 2 all over 2. LHS equals RHS. So therefore P of k plus 1 is true if P of k is true. So therefore, hence, by the principle, mathematical induction, P of n is true.